Alrighty, we have here, this particular card is from a VOX Continental, and this is a G-sharp card. And one of the things we often do is we don't necessarily test the cards or repair the cards while they're in the VOX itself. One of the reasons is you can't get to some of the items you want to check. And the second reason is that repairs are much easier done on the bench with a power supply. This particular power supply here is variable: 3, 4.5, 6, 7.5 volts, 9 volts, and 12 volts. So the power supply, it's presently set to 6 volts. And as you can see, the power supply in the VOX is 6 volts. And the bit with the 2 resistors in here is they're not really needed for resistors. It's just that the pins don't make contact unless I slide a resistor wire in them. In any case, you can find that we have an oscillator, coil, and master oscillator. That's divider 1, divider 2, divider 1, divider 2, divider 3, divider 4. When we get to divider 5, it's absent. Now watch what happens on divider 5. I'm going to raise the power supply voltage to 7.5 volts, and divider 5 now comes alive. When this happens, this is caused by electromigration in the junctions of the transistor over a period of 40 years, and what happens is its beta starts to fall. It doesn't. You may have 2 diodes in it. So in other words, if you read this with your diode scale of your meter, it's going to read as a good transistor. It's not going to be any good because its beta has fallen over the years. And electrically, what's happening is that while it's still 2 junctions, and it will read as a diode, it won't operate as a flip-flop unless the voltage is high enough. And if you turn this back down to 6, you'll find that it might run and it might not. In this case, it's not running. There we go. That's your 6th flip-flop, and there's your 5th one. So what you're going to have to do is replace the transistors. And in this case here, this is divider 1, 2, 3, 4, and that's 5. So that means these 2 are going to be replaced. And you want to replace them as a pair. Now, if you have transistors that have been matched already, and we can sell you ones if you don't, that are made for flip-flops, these transistors have been selected for high beta. And the reason for that is that the flip-flops require something with a higher rating on it than, say, a preamplifier. Preamplifiers can work with as little as 50 to 100. In the case of a flip-flop, you want a nice sharp edge on there, and so therefore the beta will be, say, above that, maybe 175, 200, maybe even 300. In some cases, the higher the beta, the better the flip-flop runs. We're removing the transistors now to show you this is the case. And you're going to make one little notation. The original transistor is on the VOX with the flat side up and the leads towards you, or ECB. So on the original here with the flat side up, and this lead here is E, this is C, and this is B. So you want to make sure you make note of that, because the ones that we will send you are a little more modern. They're a different style, and what they are is, with the flat side up, that's E right here, and that's B, and that's C. So what you've got to do in order to get this to fit in the board correctly is you've got to transpose the leads. Now be careful where these 2 cross. You're going to have to put a little twist on the transistor so they don't short out. If they do, then there will be a problem. Now, if in the event you, before you change transistors, if for some odd reason the voltage is raised to 7.5, say instead of 6, and your transistor does not want to oscillate, go up to maybe 9. If it does not oscillate at 9 volts, the plate, the plate this time right there, the RC plate is bad. And that one we can also sell you, but the problem is that what happens to them is they're monolithic plates. They're made, when you see the resistors and how they're made on that, they're painted carbon stripes on a ceramic background, on a ceramic substrate. And what happens is they're joined by painted silver wires. And after 40 years, they degrade to the point where they may not even run. Now I'm going to try to insert transistor number 2. There we go, number 2. I'm going to bend the leads slightly over. I want to keep the leads a little longer than usual, so that I have a spot to work with on the transistor. We're going to solder number 2, and then what we're going to do is we're going to make sure they don't touch between base and collector. Remember that little twist that we came up with. You can also try a little sleeving on the transistor if the lead's long enough. Now in this case here, we're going to take the transistor and give it a slight twist. Alright, so this way here, we can get that into the light. There we go. And we're going to move the base lead so that it doesn't touch. And in this particular instance, we're also going to sit there and move the base lead, and we're going to push the collector lead the other way and give the transistor a slight twist. Okay, there's not much room on these cards for some of this, and now what we're going to do is we're going to re-establish our power supply connections. That's ground on pin 7, and that's plus 6 volts on pin 10. So there we're going to check our master oscillator, which is still running, and then divider 1, divider 2, divider 3, divider 4, divider 5 is now running, see? That's with the new transistors in it. And now divider 6 is running. So there you have an example of how a transistor can read good on your own meter and still be bad. That happens. And the end result is that you'll have to change the transistors, because if the beta is not high enough, it won't oscillate. We're going to substitute a card from one of the other footages, and actually this one here, this one here, this one here, and this one here. They show all this is all being running, so these 4 dividers are okay. And now we're going to go up and substitute this into the connector. Since all the connectors are identical, we'll get away with this part. Ah, no, it is running. That's interesting. It is running. The last 3 do run on that card. Alright, but if we take this card and put this one in, let's see, the one that doesn't work is this blue wire. And that runs into this capacitor, which is an 047, into a 10K. That goes in here. that is set up as plate number 2 here, or rather more likely plate 5. This is the lowest note in the divider scheme. So we're going to try putting it back in. I'm just kind of curious if it works if you bend the card. No, that doesn't work. That one does. Okay, hold on. That doesn't work and the other one does. That comes through. There's no short here. Well, let's see. Tell you what we'll do. We'll bridge an 047 across there and see if the problem comes back.